Welcome to the video lesson for more rates of change. We're going to begin with a couple of review questions from the previous two lessons. So go ahead and hit pause now, fill out all of the your turns, and then go ahead and check your answers and see how you did. All right, so we can see here that I found f of -5 to be 0, and I found f of -4 to be 2, and then I plugged that into our slope formula to find the average rate of change between -5 and -4, and I got that 2 was that average rate of change for that interval. To find the instantaneous rate of change along that tangent line that had been drawn for us, I estimated one point to be -2,5 and one point to be -5,1. I then found the slope between those 2 points on my tangent line, and I got 4/3 to be my instantaneous rate of change at x equals -4. And that should make sense because that portion of the graph is a little less steep at -4 than it is between -5 and -4. For your turn C, I alternated some colors here, so you can see at each point I drew a tangent line here just to the best of my ability to make sure that we're touching that point on the outside, but we were definitely not crossing through it. And then for that last question, between 4 and 5, so at 4 I've got my tangent line, at 5 I've got my tangent line, and I can see that at 5 the tangent line is noticeably steeper, so that's going to give me a greater rate of change. All right, we're going to go ahead now and try to identify what type of rates of change we have and then what the function is doing. So at -4, again, I can see that that line is definitely going up, and my function is also definitely going up. So I know that at that point, my function is definitely, and I know that it is increasing, giving me a positive rate of change. I then can do the same thing for my other points. I can see that at -1, the graph is going down. My tangent line is also going down. So this one is going to be a decreasing function, and it's going to give me a negative rate of change. At x equals 1, that's kind of like x equals 1 is again a decreasing function, and it is going down, so our function is also negative. At 2.1, that is kind of a trick question here, based I see I have a horizontal line, which means that it's not increasing or decreasing. There actually is no change here. I'm just going to put a no change. And we have a rate of change that is actually 0. It's not positive or negative. And then we already talked about at 4 and 5 that they're both increasing. And because they're both increasing, we also have a positive rate of change for those as well. Okay, let's go ahead and try and connect some more dots with our rate of changes. Okay, so we can generalize here. If the rate of change of our function f is positive, then that means that the graph of x is increasing. We'll just put an I here for increasing. If the rate of change is negative, then that means that the graph of f is decreasing. So we can kind of make those connections now that we have this. And we can go ahead and draw some lines here to kind of talk about how concavity plays in this whole thing. So I'm going to draw a couple different tangent lines here. To begin with, let's say I'm just going to pick a couple points here. If I were to draw my tangent line, again, I know that my function is definitely decreasing, and I know that my tangent line is decreasing, so I have a negative rate of change and a decreasing function. If I move over to my next point, I know the function there is increasing. I also know that my rate of change is increasing, so I have a positive rate of change as well. And then for our last point over here, same idea. I know the function there is also increasing. I know my rate of change is going up, so it's a positive rate of change. Now there's a couple different observations we can make here, but one general observation we can make is as I draw my tangent lines, and maybe if I can draw a couple more to kind of demonstrate this point a little more. Oops. If I draw a couple more, having trouble drawing my tangent lines, I can see that I gradually shift from being a negative or a decreasing function into being a positive function. So what we notice about our tangent lines is they are shifting from being decreasing rates of change or negative rates of change to being a positive rate of change. If you look at our concave down function, we're going to have a opposite effect. So we start with something that is an increasing function. So we're going to have a positive rate of change. And as I draw these, we can see it's getting smaller and smaller until we get to 0. And then on this other side, now we're going to have a decreasing or a negative rate of change. So we have the opposite shift. With concave down, we're going to shift from being a positive rate of change to being a negative rate of change. Okay, so now we're going to kind of try to generalize what the tangent lines help us determine about concavity. So again, looking at the one on the left, the one that's concave up, we know it's shifting from a negative to a positive. So something that we can say is that the rate of change is increasing because it's coming from this negative value and very slowly turning into a positive. So the rate of change itself is going to be increasing. Then that tells us that the graph is going to be concave up. If you look at something as concave down, again, we start with a function that has an a positive rate of change. But that positive rate of change is slowly turning into a negative rate of change, which means that that rate of change overall is going to be decreasing. So as we go from a positive number into a negative number, we know that we're decreasing because we're getting more and more negative, and that tells us that the function is actually concave down. Okay, now we're going to try and piece everything together in terms of increasing, decreasing, concavity, then also a rate of changes. So looking at the graph on the left, we can see this one is definitely going to be concave down, but we're going to go ahead and list all the descriptors for this. So it is definitely a function that is increasing, and I know it's increasing because we are going up. It is also going to be concave down. I know it's concave down because it's facing down versus facing up, or like our parabola shapes here. The rate of change itself is going to be positive. And I know it's positive because the graph is increasing, and because it's increasing, we know we're going to have a positive rate of change associated with that. When we look at that rate of change, we see it's rather steep here, but then as we continue through the function, it starts to flatten out a little bit. So that rate of change is actually going to be decreasing. So we know we have an increasing function, but it's increasing at a slowing pace. So our rate of change is going to be decreasing, becoming less and less positive. Okay, we're going to try and create these relationships with all of our functions or all of our possibilities or combinations with concavity, increasing, decreasing, and also our positive and negatives. So let's take a look at a couple more graphs and see if we can make these matches. When we look at our first graph, I notice right away that it's above the x-axis, so I know that this is going to be a graph that is definitely positive, but it is in a downward slope, so I know that's a decreasing function. Because it's positive, but it's also decreasing, that tells us a little bit about concavity. We know that the rate of change is going to be negative, again, because it's a decreasing function, but the rate of change is going to be actually increasing, and it's increasing because we come from a fairly steep negative value to a much smaller negative value. So that rate of change is actually increasing because it's becoming closer and closer to a positive value. Okay, looking at our next function, we can see that this function is for the most part below the x-axis. We can't see what happens outside of that. So I know that this one is going to be a negative function, but it is definitely an increasing function, but we can see that it is definitely sloped upwards. When we talk about that rate of change, I see that I initially have a rather steep rate of change, and that rate of change is going to start to flatten out. But because it is going up, I know that this is definitely going to be a positive rate of change. But again, because of the fact that it's starting to flatten out a little bit, I know that it's increasing at a decreasing rate. All right, we have one more graph to look at here, and I want you to go ahead and try and select all of the terms that are correct, and then check back in and see how you did. So hit pause now, circle the answers, and then check back in. All right, so here I have my answer for this. Again, looking at just this portion of the graph, it's above the x-axis, so it's a positive function. We know that it is going to be decreasing because it's sloped down. And again, because it's sloped down, we know that we have a negative rate of change, and we have a rather flat-ish rate of change to begin with, and it starts to become a little more steep as we go down. So it is actually a decreasing rate of change because it's becoming more negative. All right, that does it for our notes. Go ahead and get started on the homework, and good luck.